Hello, students. All right, it's lab day for us. And so we are going to begin our lab activity. Please open your books to page 53, the lab activity there. And as you do, I'm just getting my slides ready here for us. And today's lab is all about a specific simple machine called the pulley. And if you notice in your lab, the problem states, how do fixed and movable pulleys help you do work differently? Now, before you write a hypothesis, let's just talk about it here for a moment, okay? A fixed pulley is not one that was broken and has been fixed. It's not that type of the word usage. So let me just explain to you using a couple of diagrams here to illustrate to you what is the difference between a fixed pulley and a movable pulley, because all pulleys move around, otherwise they wouldn't work very well. So here's the difference. Don't look at the bottom two diagrams, but look at the top two diagrams. Top diagram on the left, this is an example of what is called a fixed pulley system. A fixed pulley system means that the pulley itself is fixed in position. The pulley does not move up or down itself. The pulley is fixed in position. So if the rope or the chain goes around the pulley, the resistant force, the object that you're trying to lift, is on one end of the rope or the chain, and you or the object that is pulling the effort force is on the other end of the rope or the chain. So a fixed pulley system, the pulley doesn't move up or down. In the second diagram here, you'll notice a little difference where the rope or the chain is fixed in position and it goes around the pulley, and the effort force is in the opposite direction, and the resistance force is down here. But in both cases, the object is being lifted off the ground. But notice the difference in the direction of the effort force. In this example with a fixed pulley, the effort force is down. In this example of what is called a movable pulley, and it's called a movable pulley because as the effort force is pulled up, the pulley also moves up with the object. So this is the difference between a fixed pulley and a movable pulley. With a movable pulley, the whole pulley moves up as well. So the question of your lab is asking, how do fixed and movable pulleys help you do work differently? I'll let you look at these two diagrams and think about it, and I'll give you a moment to write your hypothesis. All right, we are back here now, and I am going to be summarizing your procedures. I will do this activity so that you can watch and make your observations, and you can make the calculations, and you can come up with a conclusion based on your observations. So let's begin. And it says, with step 2 here, determine the weight in newtons of the object. This is the resistance force. And by the way, in your observation section, you will notice there are sections for the fixed pulley, the movable pulley, and multiple pulleys. But for all of them, we are going to be using the same object. We're going to lift the same object. And so right now, we're going to scoot over to the lab view so that I can show you the apparatus that we are using here. Now, unfortunately, you can't see the entire thing, but I have a ring stand set up here with a ring at the top and a little hook in the form of a large paper clip that's opened. And we're going to be using this to attach things to. But in all of the examples we go through today, we're going to be lifting this object. This object is a 500-gram mass. But remember, that's the mass. We want to find the force or its weight. Does anybody remember what tool do we use to measure the weight of something? Okay, we use a balance to measure mass. We use a scale to measure weight. So I have a spring scale here, which is calibrated in newtons, and I am going to hook up this object to our spring scale and try and hold it up to the camera here for you to be able to read how many newtons heavy this object is. Now, if you're having difficulty seeing, I will tell you this object weighs or is being pulled down with a force of 5 newtons. So in your book, for the resistance force of this object for all of our trials is the same. We're using the same object each time. So you should write down 5 newtons for the resistance force, or F sub R. Resistance force is the same. So we've done that. What is the next step? Well, the next step is to construct a fixed pulley and use it to lift the weight. So this is the easiest one. All we do is take one of our pulleys, and we're going to hook up our pulley to our paperclip hook on the ring stand. And I believe you can see this on the camera. Very good. There we go. So we have a fixed pulley. The pulley itself is not going to go up or down. And we're going to be lifting this object by feeding a string through the pulley, which, remember, a pulley is a grooved wheel around an axle. And I'm going to attach one end of the string to this weight that we're going to be lifting. And the other end of the string, I am attaching to our spring scale. Now I'm going to go over to another view here. Hopefully we'll be able to see this easier. So let me go to the close-up view. There we go. So here we have the brass mass, which has a weight of what? 5 newtons. And I am going to be pulling down with this spring scale to measure the force required to lift the object. So here we go. And it's in motion. So I'm taking my reading right now. While I am pulling, I am getting a reading. I know you can't see it on the camera, so I'm going to tell you what the number is. This fixed pulley system is requiring an effort force of 5 newtons. 5 newtons effort force with a fixed pulley system. So write that down, and we're going to head back here for a moment. So we have constructed the fixed pulley, and you wrote down that the resistance force is 5 newtons and the effort force is 5 newtons. Now, I'd like you to remember the equation for calculating mechanical advantage. Remember, it's F sub R divided by F sub E, or the resistance force divided by the effort force. And when you calculate the mechanical advantage, you're going to write that in your book. And remember what we said yesterday or 2 days ago about mechanical advantage. The bigger the mechanical advantage, the easier it is to do the work. So I'm not going to tell you the answer right now. You're calculating it as I speak. So 5 divided by 5, think about what that is. And the mechanical advantage, just like efficiency, is not measured with any units. You're taking a force, dividing it by a force, so those units cancel out. So mechanical advantage is expressed only with a number. The bigger the number, the easier it is to do the work. The smaller the number, it's not any easier to do the work. So keep that in mind as we move on to our next step here, which is to create a movable pulley. So I'm going to go back over to the close-up view and show you the movable pulley system. And to create the movable pulley system, I'm going to disconnect our string from our pulley up top. And remember how a movable pulley is. Our movable pulley involves attaching the pulley to the object we're actually going to lift. So what I'm going to do is attach our string, the end of our string, to the top of our ring stand so that stays in position. So I can pull on that string and it's not going anywhere. And the loose end of our string, I'm putting through the pulley that is attached to our brass mass, so that when I apply a force to this string here and pull on this string upwards, notice what happens. The pulley is moving with the object, thus the name, a movable pulley system. What we want to do is measure the force. So I'm going to attach the spring scale here to the end of our string, and let's head up to the lab view up a little higher so you can see what I'm doing. And by the way, this pulley is not doing anything. I'm just attaching the string to the hook at the top of the ring stand. So again, we have the string attached here going around the movable pulley on the bottom, and I am now lifting the object. Let's see if I can lift it into view here. There's the object. Oh, I need a ladder to stand on. There's the object with the movable pulley going up and down. But the question is, what force is required? And the force is, while I'm moving it, 2.5 newtons. 2.5 newtons are required to lift with a movable pulley system. So with our movable pulley, and hopefully you've got that diagram copied down as well in your book for a movable pulley system, you're going to be calculating the mechanical advantage in exactly the same way. And you're going to be calculating it by dividing the resistance force, 5 newtons, that's the same, divided by the effort force of 2.5. 2.5 is the effort force in that example. All right, so take a moment, calculate the mechanical advantage, and make sure you have copied the diagram of the movable pulley. All right, now the next step involves multiple pulleys, a fixed and movable pulley system. So while you're copying this diagram down, I am going to set up here in my little virtual lab a fixed and movable pulley system as illustrated in that diagram. It's a little bit more complicated, but we'll get it. We'll get it going here. So hopefully you have enough time to copy that down, and then I'll bring you over to the virtual lab and I will show you exactly how I am setting up this fixed and movable pulley system. Just going to move this down a little bit here. Da, 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 da. And it's going to take my camera angle going back and forth a couple times, I think, in order for you to see this. And this certainly does work much better when you have a lab partner to work with, but I think I'll be able to get it here nonetheless. Okay, I've got mine put together, so let me go over to the lab view. Here is the lab view. And in the lab view, what I have here is I've got our fixed pulley connected to the hook at the top of the ring stand. So our fixed pulley is not moving up or down. Let me just go to the close-up view. And with the close-up view, you can see I have a pulley attached to the object we're moving, and that is the movable pulley system. Now, if I head back up to the lab view here, I have the string attached to the bottom of the fixed pulley. It's going down and through the movable pulley groove, back up again and through the fixed pulley groove. And here's the end of the string, which I have attached to the spring scale. And so now I am going to apply a force by lifting the object, and I'll come back down to the, close-up view here. So I am pulling down with the spring scale. I'm applying the effort force here while our object is being lifted. So here it is in action, our fixed and movable pulley system here. And the force required to lift it for our fixed and movable pulley is 2.5 newtons. 2.5 newtons. Okay, so make sure you write that down, 2.5 newtons for the multiple pulley system, the first multiple pulley system. All right, now for a challenge. I'm going to head back over here to the PowerPoint view and take a moment to calculate the mechanical advantage of the fixed and movable pulley system. And then I'm going to have a little bit of fun here, okay? This is 2 fixed and 2 movable pulleys. Let's see if you can draw the 2 fixed and 2 movable pulley system here. Pay particular attention to the string, because I'm going to have to pay particular attention to the string as I feed it through 4 different pulleys. 2 pulleys that are fixed and 2 pulleys that are movable. And let's see if I can do this without it all falling apart. And we'll find out shortly. Here we go. I think I may have it here. See if, oh yeah, I think I got it. Okay. Very good. Wow. All righty then. Okay, I think I got it. So hopefully you had enough time to draw that. Let me go over to the lab view. Let's see. I'm going to bring this up, and maybe we can get. Oh boy, this might be dangerous. Hold on. Let me bring this up. Maybe we can see the whole thing in lab view here. Yes, I think we will be able to. Here we go. Okay, here we go. So I've got the string. Attached to the bottom of the fixed pulley. It is traveling through one of the lower movable pulleys, back up over the fixed pulley, back down to the movable pulley, back up one more time to the other fixed pulley. And notice these are actually 2 pulleys in one here. So this is complicated. And now the end of the string I have on the spring scale. And check this out. I'm going to give you a reading here. Are you ready for it? The force required to lift this mass is, I have to look at the right side here. Oh, here we go. Well, you know what? It is 1.5 newtons. 1.5 newtons. 1.5 newtons. That's amazing. I wish you could feel this because I am barely pulling on this at all, and it's lifting this heavy object up. It is so cool. So cool. So I'm going to give you some time now to calculate the mechanical advantage of that last pulley system. And you're going to have some time, hopefully, to discuss your observations and your findings. And I'd like to remind you to study for tomorrow's quiz. And so for now, with this video, I'm simply going to say bye-bye.